Hey everyone, quick biochemistry basics here. Let's talk about HPLC. HPLC is also known as high performance liquid chromatography or high pressure liquid chromatography. HPLC is usually a modified column chromatography. In column chromatography, a column is packed with an absorbent material like silica and the mobile phase is passed down the column because of gravity. But in HPLC, a high pressure pump is attached with the column. The high pressure pump can generate a high pressure up to 40 megapascals. The column is filled with an absorbent material which has a very small particle size. The small particle size gives a very large surface area for the sample molecules to interact. As a result, the efficiency of separation increases, giving high resolution. Let's see the components of HPLC. The column is made up of stainless steel which can withstand a very high pressure up to 50 megapascals. The length of the column can vary from 5 to 25 centimeters and have an internal diameter of 4.5 millimeter. The flow rate of mobile phase through the column is usually 1 to 3 ml per minute. The stationary phase. As discussed earlier, the stationary phase is made up of an adsorbent material that has a very small particle size. The particle size is kept uniform to obtain a better performance. Usually chemically modified silica, divinyl benzene, etc. are commonly used as a stationary phase. The mobile phase. The mixture of different solvents can be used as a mobile phase. The solvent used depends on the type of sample molecules which are to be separated. The mobile phase solvent can be polar or non-polar. The mobile phase is usually kept in the solvent reservoir. The solvent reservoir is attached with a pump which pumps the mobile phase in the column with a high pressure. Just before HPLC column, there is an injector which allows introduction of the sample in the column. The detector. In order to detect the eluate that is sample coming out of the column, the HPLC column is attached with a detector. Different types of detectors such as UV detector, IR detector, fluorescence detector, refractive index detector, mass spectrometer, electrochemical detectors, etc. can be used. The detectors are connected with a computer which collects the information. Now let's see the working of HPLC. As the sample molecules get separated, they are detected by the detector and a peak is obtained on the computer. This peak is plotted with respect to the retention time. To identify the components, we need to have standards. Let's understand this with an example. Let's say we run glucose as our sample and the peak of glucose is obtained at 5 minutes. Next, we run sucrose as our sample and the peak of sucrose is obtained at 8 minutes. Now we analyze the unknown sample for the detection of sugars present in it. Many peaks are obtained in the chromatogram. The peak obtained at 5 minutes indicates the presence of glucose. However, there is no peak at 8 minutes which indicates that sucrose was absent in our sample. The remaining two peaks are still unknown as we don't have any standards to compare their retention time. This is how the detection of sample is done in HPLC, and for the detection we must have the standards. Using HPLC, it is also possible to find the concentration of sample, but before doing so, we need to have standard curve. Let's say we take different concentration of glucose and run through HPLC. The peaks of glucose are obtained at 5 minutes, and with an increase in the concentration of glucose, the area under the curve increases. Once the standard information about the area under the curve and the concentration of glucose is obtained, just by measuring the area of glucose peak in the unknown sample, the concentration of the glucose can be estimated. Now let's see different types of HPLC. Normal phase HPLC. In this type of HPLC, the stationary phase is polar while the mobile phase is non-polar. Usually, silica is preferred as a stationary phase as silica has SiOH group, which gives its polar nature. During normal phase HPLC, polar molecules are retained on the stationary phase while the non-polar molecules move fast down the column with the mobile phase. Reverse phase HPLC. In this method, the stationary phase is non-polar while the mobile phase is polar. The non-polar molecules are retained on the stationary phase while the polar molecules move fast down the column. Size exclusion HPLC. This method is based on size exclusion chromatography or gel permeation chromatography. In this method, the stationary phase particles are porous. As a result, small molecules get inside the pores and takes a long time to move, while the large molecules easily pass down the column. Hence, separation occurs based on the molecular size. Ion exchange HPLC. In this method, the stationary phase has an ionic charge. If the molecules of interest has a positive charge, then a stationary phase is kept negative. And if the molecule of interest has a negative charge, then the stationary phase is kept positive. Hence, separation occurs based on the molecular charge.